Greetings and welcome. If you are a future elementary educator, this screencast takes a look at how to solve systems of equations, particularly systems of linear equations. And when we talk about systems of equations, what we really mean is that there is some line in our scenario and some other line in our scenario, and we are interested in finding out where those two lines come together. Now, there are lots of ways to figure that out. One way, an obvious way, would be to graph the system. So y equals 2x plus 1. Well, what does that mean? We know that this number at the end is the y-coordinate of the y-intercept. So the red line has a y-intercept of 1. And we know that this 2 in front of the x, that's a slope. And so slope is rise over run. The slope is rise over run. That's up 2 and right 1. So we go 2 up, 1 over, 2 up, 1 over, 2 down, 1 to the left, 2 down, 1 to the left. This is the line y equals 2x plus 1. This is the line. The blue line has a y-intercept of 3, 1, 2, 3, and the blue line has a slope of 1. It's a slope of 1. That's up 1, right 1. Up 1, right 1, or down 1, left 1. It really doesn't matter. This is the blue line. So when we solve this system, the solution to the system is the point where those two lines come together, which appears to be this point right here, which appears to have an x-coordinate of 2 and a y-coordinate of 5. And it's pretty straightforward. 2 plus 3 is 5. Double 2 plus 1, that's 5. 2, 5 is definitely the solution to that system of equations. And we can find that by graphing. Now, we don't have to find that by graphing. Graphing is really nice if the lines are easy to graph and if the solution is nice whole number coordinates. But what if it isn't? Well, there's a second method called substitution. Let's take that same system. Y equals 2x plus 1 and y equals x plus 3. Let's take that same system and let's recognize that this thing is equal to y and this thing is equal to y, and y is the same in both cases, so these must be equal to each other. It must be that 2x plus 1 equals x plus 3. And we can solve that using tools in our algebraic toolbox to arrive at x equals 2. Now, I had said on this slide that the solution to the system is the point at which the lines come together. That's still true. We still need an x-y pair. So how do we figure out the y that goes with this x? Well, either of these equations have y values that can be found. If x is 2, 2 times 2 plus 1 is 5, or if you prefer, 2 plus 3 is 5. And so the solution to the system is the point 2, 5. Even if we do the work algebraically, the answer is an xy coordinate pair. But that's not the only way we solve systems. This is the one you're most familiar with. Juan and Maria go to the movies. Juan buys 2 popcorns and 3 boxes of candy, and that costs $22, maybe? Maria buys 3 popcorns and 1 box of candy, and that costs maybe $19. And we want to figure out how much a popcorn or a candy was. And this is all doable. You could try guess and check if you like, or you could try solving one of these for C or for P and then graphing in a PC plane, but that's just weird. Let's try to eliminate one of the variables. And the most common way we try to eliminate a variable is we say, man, if only we could get these coefficients to be the same. This 3 and this is a 1. If only we could get those to be the same with maybe opposite sign. And so the way we do that is we turn this into a -3, and we turn that into a -3 by multiplying both sides of that second equation by -3. Why do we do that? Well, the first equation stays the same. The second equation, -3 times 3p, -3 times c, -3 times 19, and then we add the equations together. Because if these things are equal and these things are equal, then adding them together maintains the equality, except that no more c's. Instead, we have 2p minus 9p, that's -7p, and 22 minus 57, that's -35. And so we can divide by -7, divide by -7, and figure out that a popcorn is $5. And if a popcorn is $5, we can figure out what C is, because 2 times the price of a popcorn plus 3 times the price of a candy is $22. And so you can solve this using all the tools in your algebraic toolbox. A box of candy is $4. So depending on which ordered pair, which way you go, I'm going to say that CP is 4, 5. I'm going to say that a box of candy is $4 and a popcorn is $5. So this definitely helps if graphing the lines gets too complicated. The slope is too weird. Maybe the intersection point isn't a nice whole number, and you want to know exactly what that intersection point is. Elimination can be very helpful. I'm going to do a second screencast that does a few more examples of the algebraic methods so you can see them, and I hope that they are helpful.